The following table lists the heart rate or pulse of an athlete running a 400-meter race. The race lasts 50 seconds. So we see time in seconds. We have values of 0, 20, 30, and 50, and a heart rate in beats per minute of 100, 134, 150, 180. Part A. Does P of t equals negative 1 over 300 times t squared plus 53 over 30 times t plus 100 model the data in the table exactly? Explain. Part B. Does P of 60 have significance in this situation? What should be the domain of P? Here I've written the important information, the table plus the function that models the data. To find out if in fact this function models the data exactly, we need to substitute each of the time values and find out if they yield each of the heart rates respectively. So let's start with P of 0. So we substitute 0 for t. We have negative 1 over 300 times 0 squared plus 53 over 30 times 0 plus 100. Now, of course, 0 squared is 0. 0 times this fraction will be 0. 0 times this fraction is 0. And therefore, P of 0 is 100. In that particular case, it checks in that the value of 0, that is right at the beginning of the race, the heart rate should be 100. Now let's find P of 20. So we substitute 20 for the value of t. So we have negative 1/300 times 20 squared. Then we have plus 53 over 30 times 20 plus the 100. 20 squared is 400. So we have negative 400 over 300. 20 multiplied times 53 gives us 1,060, and that's over 30. And then we have the plus 100. In order to do this calculation, we need to have the same denominator for all three terms. So what we can do is make it all 300, and that would give us negative 400 over 300 plus 10,600 over 300 plus, multiplying that by 300, we get 30,000 over 300. Adding all of those together, we have a negative 400 plus 10,600, so that would be 10,200 added to the 30,000, so 40,200 divided by 300. When we work that out, that equals 134. And once again, we'll check that because, in fact, the time of 20 seconds should yield a 134. So far, the model is exact. But we still need to check P of 30. So let's do that. P of 30 will be equal to minus 1 over 300 times 30 squared plus 53 over 30 times 30. And then plus the 100. 30 squared is 900. So what we have is negative 900 over 300. The 30s here can cancel, leaving us with just plus 53, and then we still have the plus 100. Notice that 300 will divide into 900 exactly 3 times. So we have a negative 3, which I will now put up here and cross that out so there's no confusion. Negative 3 plus 53 is 50, plus 100 is equal to 150. And once again, it checks because a time of 30 seconds here should yield 150, and it does. The final numbers we have to check are, does P of 50 equal 180? So this would be negative 1 over 300 times 50 squared plus 53 over 30 times 50 plus the 100. Now 50 squared is 2,500, so we have negative 2,500 over 300. Then we have 53 times 50, and that's going to yield us 2,650 over 30. Then we have plus the 100. Once again, to combine all of these, they need to have the same denominator, so let's make them all 300. So we would have negative 2,500 over 300 plus, here we need to multiply both by 10, so that would give us 26,500 over 300 plus, here we have to multiply by 300, so that gives us 30,000 over 300. Now we can, in fact, combine the numerators. When we do this, negative 2,500 plus 26,500 yields 24,000. Add that to the 30,000, and we have 54,000 over 300. When we divide that out, it will equal 180, and that then checks. So we can conclude for part A that the model does fit exactly the table of data. Now, for part B, it asks the question, does P of 60 have any significance? Well, P of 60, that means we'll have a time of 60 seconds. However, we were told in the original problem that the race lasted only 50 seconds. So P of 60 has no significance for this particular problem. And the last thing we wanted to find, or that we were asked to find, was the domain of the function P of t. Well, the domain refers to those values of t that are part of the function that we can substitute in. That is, we look at the race and we know that the time started at 0 and it ended at 50 seconds. And so our domain would be 0 to 50 inclusive of both endpoints.